All right, here we go. Our 8th lessons homework assignment. We had a lesson on differences of squares. And that's really what the first question is asking about. It says match each quadratic expression given in factor form with its equivalent expression in standard form. One expression in standard form has no match. And we have y plus x, y minus x. That is a difference. Those are conjugates, which means they would expand and multiply together into a difference of squares. Y squared minus x squared. Boom, right there. B, I have 11 plus x, 11 minus x. Again, those are conjugates. They would multiply together. The middle two terms would drop out. 11 squared is 121. X squared is x squared. I know that that is 121 minus x squared. X minus 11 times x plus 11. Again, conjugates. X squared and 11 squared is 121. So I have a difference of squares. X squared minus 121. And last one, I have conjugates. X minus y, x minus y. Oh, wait, they're not conjugates. I need to actually multiply these out. If I were to multiply these out, we're going to notice something. Instead of having those middle two terms cancel, I'm going to have two terms that are identical. And I'm going to have minus xy twice. So this is going to match up with minus 2xy. And the one that doesn't have its match is up here, number 2. 2 says both x minus 3 times x plus 3 and 3 minus x times 3 plus x contain a sum or difference and have only 3 and x in each factor. They're both conjugates. And each expression is rewritten in standard form. Will the two expressions be the same? No. And if you want to, you can just multiply it out to show. X minus 3 times x plus 3. When I start the distribution, I end up getting x squared plus 3x minus 3x minus 9. The middle two terms are going to cancel, and I'm going to be left with x squared minus 9. However, if I do the 3 minus x and the 3 plus x, same thing, I'm going to get 9 plus 3x minus 3x minus x squared. Those middle two terms are going to cancel. Now I'm left with 9 minus x squared. So they have signs backwards. 3a says show the expression 5 plus 1 times 5 minus 1 and 5 squared minus 1 are equivalent. Well, there's a lot of different ways I can do this, but probably the quickest way here is because we're just trying to show that they're equivalent. 5 plus 1 is 6. 6 times 5 minus 1 is 4. We know 6 times 4 is 24. 5 squared is 25. 1 squared is 1. 25 minus 1 is 24. They check out. They're the same. B says the expression 30 minus 2 times 30 plus 2 and 30 squared minus 2 squared are equivalent and can help find the product of two numbers. Which two numbers are they? Well, they're the numbers that are a little bit below 30 and a little bit above 30 by 2. This is really the same thing as 28 times 32. C says write 94 times 106 as a product of a sum and a difference as conjugates, and then as a difference of two squares. What is the value of 94 times 106? Well, I can tell that 94 and 106 are both 6 away from 100. So I really have 100 minus 6 and 100 plus 6. There they are as conjugates. And I also need to write them as a difference of squares, which means I can write this as 100 squared minus 6 squared. And I actually need to figure out the value. Well, the value of this 100 squared is a big number. It's 10,000. 6 squared is 36. So I really have 10,000 minus 36, which is just 9,964. Question 4. It says write each expression in factored form. If not possible, write not possible. And we have that whole difference of square idea here. A, I'm seeing x squared minus 144. That's a difference of squares. The square root of x squared is x. The square root of 144 is 12. So I have x plus 12, x minus 12. The next one, I do not have a difference of squares. I just have a sum of squares. I cannot factor that. This is not possible, at least for now. Eventually we'll learn about imaginary numbers, but for now we can't do that. See, I do have a difference of squares. The square root of 25 is 5. The square root of x squared is x. So I have 5 plus x and 5 minus x. Oops. 5 minus x. D, I have a difference of squares. The square root of b squared is b. The square root of a squared is a. So I have b plus a and then b minus a. And E, I have a sum of squares, meaning I can't do this. There is not possible to factor with what we know. 5, what are the solutions to the equation x minus a times x plus b is equal to 0? Well, using the zero product property, I know that each one of those factors would have to be equal to 0. So I know that x minus a would have to be equal to 0. Well, if that's the case, I add a to both sides. I get x is equal to a. There's my one solution. Or I know that x plus b would have to be equal to 0. If I subtract b from both sides, I get x is equal to negative b. So my two solutions are x is equal to a and x is equal to negative b. So a and negative b, that is option C. 6 says create a diagram to show that x minus 3 times x minus 7 is equivalent to x squared minus 10x plus 21. Plus 21. We've done this over and over and over again by now, so this should be by second nature about now. I have x minus 3. I have x minus 7, so I get x squared minus 3x minus 7x plus 21, and that would lead me with collecting like terms to get to x squared minus 10x plus 21, which is what we were supposed to get to. 7 says select all expressions that are equivalent to 8 minus x. Well, I have a positive 8 and a negative x. So I know that this is tying into subtractions, the same thing as adding the opposite, so I need to be careful with the signs. 8 minus x, positive 8, negative x. Well, A, I have a positive x, which means I already know I'm wrong. 8, I do see a negative x and I see a positive 8, so B works out. C, I have a negative x and subtracting a negative makes that a positive 8, so C checks out. D, I have a negative 8, doesn't check out. E, I have x subtracting a negative 8. That's the same thing as a positive 8. So in this case, it doesn't work out. I don't have my negative x, even though I have my positive 8. F, I have a positive x and a negative 8. Well, that's not what we want. And G, I have a negative x and a positive 8. The terms are just in a different order, so we get G also. 8, Mai fills a tall cup with hot cocoa, 12 centimeters in height. She waits 5 minutes for it to cool, then she starts drinking in sips at an average rate of 2 centimeters of height every 2 minutes until the cup is empty. The function C gives the height of hot cocoa in Mai's cup in centimeters as a function of time in minutes. Sketch a possible graph of C. Be sure to include a label and a scale for each axis. Well, it looks like the output of this function is going to be the height of the hot cocoa. And I need to get up to 12, so I can actually scale by 1. So let's see here. 0, 2, 4, 6, 8, 10, 2, so on and so forth. And this is the height in centimeters. Which means I'm going to have a y-intercept, a vertical intercept of, I started off with 12 centimeters of hot cocoa. And I know that every 2 minutes, I'm drinking 2 centimeters. So my slope is negative 1, 2 down 2 over 2. So I'm just going to keep my scale the same on my horizontal axis. 2, 4, 6, 8, 10. My inputs are time. 2, 4, 6, 8, 10. And this would be time in minutes. So 2 minutes later, instead of having 12 centimeters, I had 10, and then I had 8, 2 minutes later, and then I had 6, and then you can see your slope of, if I could count, 2, 4, 6, 8, 2, 4, 6, 8. Oh, it would help if I could count, huh? Let's try this again. There's 10, and here would be 12. So 12 is way up here. There we go, that looks a little bit better. And every 2 minutes we'd be going down 2 centimeters. My graph would look kind of something like this. And there is showing my drinking her hot cocoa. What quantities do the domain and range represent in the situation? Well, my domain is my set of my inputs, which in this case is t, so my domain is representing the time. The range is my set of outputs, which in this case is height. And again, the height is in centimeters, the time is in minutes. Describe the domain and range of C. Well, in this case, it looks like the domain, the possible time in this case, I could be talking about anywhere from 0 minutes all the way up to 12 minutes of drinking, because at that point in time, it would be all taken care of. So I know that my domain would be from 0 to 12. And if I want to write this as a compound inequality, it would be t is less than or equal to 12, and t is greater than or equal to 0. My range is my output, in this case my height, and I have the same thing. I would have anywhere from 12 centimeters of hot cocoa all the way down to nothing left. So my range is also from 0 to 12, which would be from 0 is less than or equal to c, is what the function is called. So I'm going to call this c of t, which is less than or equal to 12. Nine says 2 bacteria populations are measured at the same time. One bacteria population P is modeled by the equation P is equal to 250,000 times 1/2 D, where D is the number of days since it was first measured. The second bacteria population Q is modeled by the equation 500,000 times 1/3 raised to the D power. Which statement is true about the two populations? Well, let's just go through and see if which ones make sense. A says the second population will always be larger than the first. Well, if I'm looking at the second population, it definitely starts larger because my y-intercept is 500,000 versus 200,000. But I have a growth factor, or I have that multiplier of 1/3, which means it's going to be shrinking really, really fast, more so than 1/2. So I know that eventually, even though it starts higher, it's going to get lower. B says both populations are increasing. Well, that's garbage. They're not increasing. They're being multiplied by a number between 0 and 1, which is a fraction. They're getting smaller. Half of a number is getting smaller. 1/3 of a number is getting smaller. C says the second bacteria population decreases more rapidly than the first. I think we have a winner here. The reason being is if I multiply by 1/3, I'm really dividing by 3. And if I multiply by 1/2, I'm really dividing by 2. Dividing by 3 makes it get way smaller. Now, the other way that I've seen people do this is they can say that this base of 1/2 can really be rewritten as 1 minus 0.5 to show that we are actually decreasing by 50%. The same thing with that 1/3. 1/3 could be rewritten as 1 minus 0.33, and I'm just rounding here, showing that we're decreasing, not minus 0.33, minus 0.66, 2/3. Meaning we are decreasing by 66%. And decreasing by 66% is way more than decreasing by 50%. So C is my winner. Just to double check my work, I'm going to read through D to make sure that doesn't make sense. D says when initially measured, the first population is larger than the second. Well, we've already said that that's not the case because 250 is smaller than 500. And there is your homework assignment from your 8th lesson on differences of squares.